Welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In this episode, we'll explore Zero Trust architecture and software-defined networking, or SDN. These modern approaches are transforming how organizations approach cybersecurity, network design, and threat mitigation. As environments become more distributed and dynamic, driven by cloud adoption, remote work, and mobile devices, traditional perimeter-based defenses are no longer sufficient. CISSP professionals must understand these models to effectively secure today's complex infrastructure. Let's begin with a solid foundation in the Zero Trust model. Zero Trust is not a single technology, but a security framework rooted in a fundamental principle: never trust, always verify. It assumes that threats exist both outside and inside the network, and that no user, device, or system should be trusted automatically. Traditional models often granted broad access to users or devices once inside the network perimeter. This created security gaps, especially when attackers moved laterally across networks after gaining initial access. Zero Trust shifts away from this by requiring every access request to be authenticated, authorized, and continuously validated, regardless of where it originates. A Zero Trust model involves enforcing strict access controls, monitoring all traffic, and applying least privilege policies. It significantly reduces lateral movement by isolating applications, workloads, and users. It also supports regulatory compliance by enforcing tighter controls around sensitive data and access paths. Zero Trust architecture is especially effective in environments with hybrid clouds, remote workforces, or high-value assets requiring extra protection. CISSP candidates must grasp that implementing Zero Trust means rethinking how trust is granted within systems, not just improving perimeter security, but extending granular protection across the entire enterprise. Now let's look at what it means to implement Zero Trust in practice. Several core principles form the foundation of this architecture, and they must be applied holistically. First is identity verification. Every user and device must be strongly authenticated before gaining access. This means enforcing multi-factor authentication, MFA, across all entry points. Passwords alone are not enough. Authentication must prove both who the user is and that they are operating from an authorized device. Second is microsegmentation. This practice divides networks into smaller zones, where each segment enforces its own security policies. By doing so, you can prevent attackers from moving laterally across systems. Even if one segment is compromised, the rest of the environment remains protected. Third is continuous monitoring. In a Zero Trust environment, access decisions are not one-time events. Just because a user authenticated successfully at 9 a.m. doesn't mean they should retain access all day. Behavioral analytics, endpoint telemetry, and real-time analytics are used to detect anomalies and revoke access dynamically. Fourth is adapted access control. Access decisions should consider context, such as user behavior, device posture, and geolocation. If a user typically logs in from a corporate laptop in Chicago but suddenly tries to access sensitive systems from an unrecognized mobile device overseas, access can be blocked or flagged for review. Finally, policies must be reviewed and updated regularly. Roles change, new threats emerge, and business needs evolve. A Zero Trust approach must remain dynamic, never static, to remain effective. Let's pivot now to software-defined networking, or SDN. This is a networking paradigm that separates the control plane from the data plane. In traditional networks, each router or switch is responsible for forwarding traffic and making routing decisions. In SDN, those functions are centralized. An SDN controller becomes the brain of the network, dictating how traffic should flow, applying policies, and managing routing. The switches and routers simply forward traffic based on the controller's instructions. This decoupling enables dynamic, programmatic control over the network, which is extremely powerful for both performance and security. SDN simplifies network configuration and reduces human error. It allows security policies to be applied and updated in real time across large distributed environments. It also provides enhanced visibility because the controller sees the entire network topology and traffic patterns in a centralized manner. For CSSP professionals, it's important to understand how SDN supports agile, scalable, and secure architectures. Whether implementing microsegmentation, isolating workloads, or deploying rapid incident response mechanisms, SDN can play a foundational role. Let's pause for a moment to talk resources. For more information on CISSP certification and other valuable cybersecurity training, visit cyberauthor.me. You'll find best-selling books, exam prep tools, and in-depth resources tailored for cybersecurity professionals working toward certification and career advancement. Now, let's talk about how to secure SDN environments. While SDN offers many benefits, it also introduces new risks, especially because the centralized controller becomes a high-value target. First, the SDN controller must be heavily protected. Use strong authentication, access controls, and secure management interfaces. The controller should be isolated from general network access and closely monitored for any signs of unauthorized activity. Second, secure communication between the controller and devices is critical. Protocols like OpenFlow should be protected using encryption and integrity verification. Any tampering with control messages could allow an attacker to reroute traffic or disable security measures. Third, implement role-based access control for administrators and network engineers. Not every admin needs full access to SDN policies or configurations. Define roles, responsibilities, and approval workflows. Fourth, regularly update and patch all SDN components, including the controller and network devices. Many SDN tools are software-defined and may be exposed to vulnerabilities that can be mitigated through timely updates. Fifth, integrate your SDN with security monitoring and analytics platforms. Because the controller has visibility into traffic flows, it can provide valuable telemetry to SIEM systems, intrusion detection tools, and behavioral analytics engines. Securing SDN isn't just about protecting infrastructure. It's about using the centralized intelligence of SDN to enhance your security posture across the board. Let's now tie Zero Trust and SDN together. These two approaches are highly complementary. SDN enables rapid, granular enforcement of Zero Trust policies across the network. It gives administrators the ability to define fine-grained security rules and apply them instantly without needing to reconfigure dozens of firewalls or switches. For example, when implementing microsegmentation, SDN allows you to isolate workloads based on user roles, device types, or data sensitivity, without changing the underlying physical network. When combined with continuous monitoring tools and behavioral analytics, SDN helps enforce adaptive Zero Trust decisions dynamically. If a workload behaves suspiciously, SDN can quarantine it automatically or reroute traffic for inspection. From a governance standpoint, both Zero Trust and SDN support strong auditing and compliance. Every access request is logged, every network flow is visible, and every policy change is documented. But implementation must be strategic. Both Zero Trust and SDN require collaboration across security, networking, and operations teams. Policies must be defined jointly, tools must be interoperable, workflows must support agility and accountability. As with any system, continuous improvement is necessary. Regular reviews of Zero Trust configurations and SDN policies should be conducted in light of new threats, business changes, and compliance requirements. Incident reports and audit logs can reveal blind spots or misconfigurations. Update your authentication systems, refine your access policies, and improve your monitoring rules accordingly. Cross-functional collaboration is vital. CISSP professionals must help bridge the gap between technical teams, compliance officers, and business leaders to ensure these models deliver value and maintain resilience. Keep training your teams. Both Zero Trust and SDN involve new technologies and mindsets. Make sure your staff understands how they work, what they protect, and how to manage them effectively. In conclusion, Zero Trust and software-defined networking are at the forefront of modern cybersecurity strategy. They empower organizations to defend against complex threats, adapt to rapid changes, and enforce security policies at scale. For CISSP candidates, mastering these concepts is not just about passing the exam, it's about preparing for leadership in a rapidly evolving security landscape. Thanks for joining us for this episode of the Bare Metal Cyber CISSP Prepcast. For more episodes, tools, and study support, visit us at baremetalcyber.com.